Zoom session is being brought to you by the Fractal Peace Anchor B. All right. Now this today we'll be doing 7.3, simplifying and combining radical expressions. That's expressions containing square and cube and higher roots. We'll also, whoops, let me try that again. I'm gonna turn that off. I'm sorry. I pushed the wrong button. Here we go. So, and 7.4 will be about multiplying and dividing and simplifying radical expressions. Now, okay, we have a square root. If it has a square factor in it, then first of all, a square root of its product is product of square roots. And a square root of a square cancels, leaving absolute value of a times b. So you have root a squared b is absolute value of a times root b. So for example, root 18. The largest square factor of 18 is 9, so that's root 9, root 2. Root 9 is 3, so we get 3 root 2. Here's root 75. The largest square factor of 75 is 25. That's 25 times 3. Root 25 is 5, so you get 5 root 3. Here's 8 root 45. The largest square factor of 45 is a 9, so 8 root 9 root 5. Root 9 is 3, so 8 times 3 root 5. 8 times 3 is 24, so 24 root 5. Now here we have root 128, a to the third, b to the fifth. Now I want to find the largest square factors of 128, a to the third, b to the fifth. Now 128 is 2, 4, 8, 16, 32, 64, 128. 2 to the seventh power. So that's one factor of 2 too many. The previous one is 64, so 64 times 2. Now we want to find a square factor of a to the third, which is basically saying what's the largest even number no bigger than 3? Well, that would be 2. So a squared times a to the first. What's the largest even number no bigger than 5? Well, it'll be 4, b to the fourth times b. So all right, root 64 a squared b to the fourth, root 2ab. Now root 64, that's 8 squared, so we get an 8. Root of a squared is a to the 2 halves. Root b to the fourth is b to the 4 halves. So in the end, you get a, 8a b to the second, root of 2ab. Now similar things happen for simplifying higher roots. Look, you have an nth root of something, you look for the largest nth power in the root, and it comes out to be a times nth root of b. So for example, cube root of 54. The largest cube factor of 54 is 27. 27 times 2. Cube root of 27 is 3, so you get 3 cube root of 2. Here's the fourth root of 32, a to the fifth, b to the 10th. Now 32, let's see. 2, 4, 8, 16, 32. It's 2 to the fifth power. Largest fourth power, therefore, would be the fourth power of 2, 16. So 32 is 16 times 2. Look at the largest fourth power factor of a to the fifth. That will be a to the fourth times a. Largest fourth power factor of b to the 10th is b to the 8th times b to the second. All right, fourth root of 16 is 2. Fourth root of a to the fourth is a. Fourth root of b to the 8th is b to the 8th fourths, or b to the second. So we have 2ab to the second times fourth root of 2ab squared. Now, we have a long expression with several different roots in it. What we want to do is combine like roots. Here's 5 root 2, here's 4 root 2. These are like roots. Here's 3 root 2, 3 and 2 root 3. These are like roots. So these add up to 5 plus 4 times root 2. These add to 3 plus 2 root 3. And so 9 root 2 plus 5 root 3. Now here we have root 98 minus root 50 minus root 72. The thing is to first simplify all these roots and see which ones are like. 98 is 49 times 2, so root 49 root 2. 50 is 25 times 2, so root 25 root 2. And 72 is 36 times 2, root 36 root 2. Root 49 is 7, root 25 is 5, root 36 is 6. So 7 root 2 minus 5 root 2 minus 6 root 2. At 7 minus 5 minus 6 all times root 2, which comes out to negative 4 root 2. Here you have root 18t plus root 300t plus minus root 243t. Now the largest square factor of 18 is 9. So you have root 9 root 2t. The largest square factor of 300 is 100. So you have root 100 root 3t. The largest square factor of 243 is 81. Let's get root 81 root 3t. So this comes out to 3 root 2t. This comes out to 10 root 3t. This comes out to 9 root 3t. Now this stays by itself. 3 root 2t just stays the same. 10 root 3t minus 9 root 3t just leaves you 1 root 3t. So 3 root 2t plus 1 root 3t. Here we have the third root of a to the 7th over 64a. Well, first of all, a to the 7th over a cancels. A to the 7 minus 1. So you get cube root of a to the 6th over 64, which is 2 to the 6th. So we take a third root of numerator and denominator. So we use 1/3 the power. A to the 6 thirds, 2 to the 6 thirds. It comes out to a to the 2nd divided by 4. There that is. Root 20 plus root 20, what's that? Root 21 plus root 21, what's that? Well, 21, there's no square factors in it, so we can't simplify any further. So this is just to be 2 root 21. Root 20 is, well, root 4, root 5. Root 20, root 4, root 5. This is 2 root 5 plus 2 root 5 here and here. Is that up to 4 root 5? Root 9x squared minus root 25x squared plus root 16x squared. What is that? Well, root 9x squared is 3x. Root 25x squared is 5x. Root 16x squared is 4x. 3 minus 5 plus 4 comes out to 2x. Although I suppose it really should be 2 absolute value of x. Now here I have a similar one where instead of squared powers, we have third powers. So we pull out a root x here, root 9x squared root x. Pull out an x here, root 25x squared root x. Pull out a factor of x here, root 16x squared root x. And as before, this is 3x root x minus 5x root x plus 4x root x. Yeah, this comes out to 2x root x. These are similar, but there's an extra factor of root x here versus here. Okay, here's some examples. Simplify root 50. Well, the largest square factor of 50 is 25. So root 25 root 2. This square root's to 5, so 5 root 2. Is 8 root 45. What's the largest square factor of 45? It's 9. 9 times 5. So 8 root 9 root 5. Root 9 is 3. 8 times 3 root 5. Therefore 24 root 5. You know, actually, did I do any of these before? I feel, oh, actually, I did all of these before. Oh, redundancy. Yes, we did all of these problems just a few pages before. Oh, well, my apologies. Anyhow, let's see if the next one is less redundant. Actually, I did the exact same thing a few pages before. I'm very embarrassed. Oh, well. All right, fine. So much for 7-3. The idea is, okay, so we can simplify roots by taking out largest square factors. All right, let's close this.